is Mr. Darren will also present, and then we've got Mr. Tom Scullion. Let's briefly talk about Mr. Scullion. So Tom is a senior research engineer in the Pavements and Materials Division, TTI. He has over 40 years experience in the areas of pavement design, forensic investigations, and non-destructive testing. His current areas of interest are full depth reclamation and high-speed deflection testing. Mr. Thomas helped me look into a couple of county roads in San Antonio, so I'm pretty thankful for that. I did ask him who his favorite baseball team is, and he said he doesn't like baseball, so that's pretty unfortunate. With the exception of his grandson's team, right? So, by the way, the Astros are down in the middle of the second, just in case anybody wants to know. So we'll go ahead and get started with Mr. Darren here.
All right, so I'm going to talk about another of the projects that we have going on, and it's develop guidelines and best practices for bonding hot mix asphalt to Portland cement concrete pavement. So some of you have maybe seen problems with this, where you've got a concrete pavement and you put an overlay, and you're generally going to put some kind of a tack coat, and then lo and behold, at some point in the future, you got some kind of shoving situation going and debonding and maybe even disintegration of the pavement. And so what's going on there and what can be done? Well, the first thing you got to do is decide what you're looking for. And so, I kind of recounted the problem statement in my opening remarks, that you get all kinds of bad things happen when this problem happens. So the goal is to identify, develop, and validate test methods, use the test methods to evaluate the impact of various factors, and propose guidelines for future selection our surface preparation techniques and materials. So we started out with a suite of tests that we would evaluate, and like my previous presentation, there's practicality, there's repeatability, there's cost, there's how easy is the test to do. Those things factor into what you decide you really want to look at. And so if a test doesn't fulfill some of those things, it may be discarded in favor of another test. So we looked at direct shear test. Variation 1 is a direct shear, and variation 2 is a direct shear with normal stress. Pull-off test, a variation of a text 243F is variation 1. Variation 2 is this same pull-off tester that I showed that really did not work, or it worked, but what we were using it on was not appropriate in that previous example, a previous project, but it holds a whole lot more promise here. And then variation 3 is using a similar pull-off procedure, but using metal discs as the substrate. So you're really testing two metal discs with a tack coat material in between, and that really isn't testing the concrete or the hot mix that's bonding to. And then there's torsional shear tests and various motorized and or non-motorized versions of that, and that was discarded fairly fast. So what we've settled on is looking at direct shear using 0 confinement and 10 psi confinement, and then pull-off tests. I showed this one via HMA, and that's really what we're doing. The direct pull-off where you're adhering something to the tack coat is not what we're doing, because you don't have the hot mix mobilized in that. Before this project, there was a previous interagency contract where some similar work was done, where there's concrete and hot mix put on it with a tack coat, and then cores made, and then shear test done. And so, this is kind of what was done on a previous, not really a contract, an interagency agreement to study this before this project was even put together. But this is some of the results from that. So if you have direct shear with 10 psi confinement, using concrete with hot mix and various tack coats, you see that some of these trackless tack materials did pretty well. You see that PG binders did fairly well. and AR binder, AC25TR, and I don't know what SAUM is, but they didn't do so well. But I know for a fact that asphalt rubber, as in the form of a chip seal, has been used successfully as the bond between hot mix and concrete in the past, and several districts use that routinely. So why did it not perform very well? And again, this was before this research project. So one of the things that you find is that you can get whatever, or you can't get whatever, but you can get different results depending on how you do the test. If I test this with a displacement controlled mode, I get a certain result. And in this case, I see that I got a high shear stress with ultrafuse, and I got lower shear stress with PG 76-22, and I got lower with the AC25TR, which kind of goes hand in hand with some of the stuff we just saw a while ago. But that may not be the best way to look at things. If you look at, now this is just testing the bond strength of the material and not the concrete and hot mix, but if you use aluminum to aluminum with the tack coat in between, but you use a load controlled mode, you get a different response. So the question is well, what kind of response should we be looking at? Should we test things in load controlled or displacement controlled mode? And which is more applicable to in use? So if the load controlled, you end up with things that are brittle, the high strength but brittle, as in the ultrafuse, or lower strength and ductile behavior. And so which is what you want? What is it that you want? So we had a field phase, which was kind of like a forensic analysis. We asked for projects where there might have been a problem, but it's hard to tell if there's a problem until you see it on the surface. And when you see it on the surface, you know that there's a problem, and you know there's no bond. So you can't test any bond strength. So we actually asked for some people to, tell us, do you have any concrete that has hot mix on it that you would like to help us with this project? And so we got some volunteers. And we tested 10 sections in several different parts of the state. Sometimes we knew what the tack coat was. Sometimes we didn't. Sometimes we knew what the tack coat rate was, and many times we didn't. Several different types of hot mix, but we did take cores and we did do pull-off tests on all of these. So here is an example of some direct shear test. So here we got, well, I'm not going to just go, you can see the error bars on this. This is generally only about 2 samples because we can't really do a whole lot of, it takes a long time to get some of these samples, especially if you're in the middle of the night in traffic. So many times it's 2 samples in 2 locations, and then that's it. So anyways, you can see various responses here. Sometimes it fails at the interface, and sometimes it fails in the hot mix. Sometimes it fails dramatically, and sometimes it does not. But if you do have high interlock, as in mechanical interlock between the concrete and the hot mix, it does take a lot of shear stress to fail it. So moving to the pull-off test. The pull-off test is done in the field. Mark off about a square foot, drill 2-inch diameter holes through the hot mix, barely into the concrete, so you know you're testing the interface. You epoxy these metal studs to the cores that are in place, and cure the epoxy, and then you pull them off with this puller borrowed from the paint industry, and you can get a strength, a pull-off strength from those. You can also look and see what happens when the thing fails. Where is it failing? Is it failing in the hot mix? Is it failing in at the bond interface? So here is those same sections that we tested and the pull-off tests associated with those. Some of the time, you can see like sections 5 and 9 are very low. And sometimes we saw that there is, like, it pulls clean off the concrete. And so you don't really get, you didn't have a good bond, but none of the things that we tested were exhibiting movement. So, you know, it's like these may be a future problem, but they aren't a problem right now. And this shows you an example. You can see the tines of the concrete, the binder that was in the tines come out. So this is another section where the hot mix broke. Another section where it came loose at the bond. Another where it's kind of at the bond. This one broke in the asphalt. This one kind of broke half and half. This one came off clean. And this one was about half and half. So some of these I would say are good results, and some is like, well, I don't know if that's really a valid result. But it is valid from the standpoint if there's no bond, then there's no bond. So a summary of the first forensic analysis, you know, we would like to develop a target for the well-bonded surface. We do know that the interlock can have significant effects that are positive. And we had to develop this temperature control system because you know that asphalt and hot mix are very sensitive to the temperature that you test it. And so if you test it out on the road, it could be hot, it could be cold, and your test is testing the condition at that temperature, and you can't do that. So you have to have a way to have a standard temperature. So we had to develop a box that we'd put over to get us our temperature control. The next thing is a lab study, and this is what's going on right now, where we have cast concrete. We're essentially casting concrete cylinders and molding hot mix on top of them in a superpave gyratory press with various tack coat materials and various surface preparation techniques of the concrete. So these are a lot of the factors that influence this, some of which can be controlled and some not. So we're looking at as many of these as we can. Here's just showing the preparation. We're casting the concrete, putting a surface finish on it, depending on whether it's tined or polished or whatever, putting a tack coat on it and molding hot mix on top of it, and then doing shear strength tests. On this project, we have UTSA involved to do some numerical modeling to look at what are critical shear stresses at various depths in the pavement, particularly at that interface. And future work, this is where I'm asking you for something. If you have any projects that is concrete pavement that you're going to overlay, or you're going to remove the overlay and put a new overlay on, we would like to get involved when this is all done so we can look at the surface of the concrete, we can watch the material, the tack coat material go down, maybe get samples of it, and then once the hot mix goes down, do some pull off and shear tests. So I would, if you have a project or you have something in mind, that would be very helpful for us. And those would be subject to some long-term monitoring and visual evaluation. That's it.
So we have time for a couple questions. Anybody have a question for Mr. Darren?
On the tack coat, were y'all using anything exotic or special, or
No, these are so we aren't doing the tack. Well, in the lab we can use tack coats, but you know, in the field it's like, what was the tack coat used? So you know, we know some of them were the trackless tack coat materials, and several of them were asphalt rubber. In the field, we have a whole lot more control, and we can use, you know, unmodified asphalt, modified asphalt. We can use the trackless tacks and those types of things. So that's where I think we're going to get a lot of our information, because we know what it is and we know how much we're putting on it.
Gentleman in the back.
Did you test not only the tangents, but at curved areas, if there was a difference on how the pavement was stressed differently due to the curve?
So the answer to that is no. In that when we did the field work, we were constrained a whole lot by traffic control. So we had to have a certain length that's fairly straight. And you know, sometimes we were on the inside lane, and sometimes we were on outside lane, depending on how it would be easier. And and Andres knows this. I have some personal experience. I was out on some of these. you know, you can't do this in the daytime. You got to do it at night, and traffic control sets up, and you finish up at 4 o'clock in the morning. And so the answer to that is no, unfortunately. We're really constrained by what is out there and what is safe.
All right, thank you.
Okay, good afternoon. I'm already getting hate mail about baseball.
Sorry
I'm
about
going to
that.
give it one more shot because I went to my 8-year-old grandson's game the other day, and it was 16-15. It was a slobber knocker, man. It was. I didn't think baseball could be exciting, but that changed my mind. I'm not doing research on bonding, but I have investigated a couple of failures, and I want to show you what we're seeing in some of the failures we've been looking at. So let me get rolling on this thing. I want to talk a little bit about the shear test that TxDOT has developed and implemented, and it's not practical for doing any testing of hot mix onto concrete. We need a test, but we don't think the shear test is the way to go. I want to show you a couple of the failures that I've looked at and some of the bonding problems, what they look at. These were forensic investigations, and we'll go through those things. I'll skip over this thing fast because I'm going to promote the pull-off test that Darren just mentioned there. I'll show you a little bit of the lab results and field results. The beauty of this test is you can run it in the lab and you can run it in the field. And I'll then give you some kind of summary. The shear test is something we worked with TxDOT 7-8 years ago, and TTI helped them develop this test. And I think Brian Wilson from TTI was one of the leaders doing this work. And it's currently a text method 249F. You have a little shear device. You take a core, you trim it off, you stick it in the shear machine in the top right there. And if that works, top right there. And then you just shear it down. You measure the force required to do that. Works fine. Many of the districts are using that, looking at different, non-tracking tax and various other things. The problem with that is when you try to look at the thing we're looking at now, of bonding to concrete, you end up trying to take a core like that. It took us an hour to take that one core. This test talks about running 3 samples to get a number. We had gravel. We had 2 layers of steel. We ain't going to do that. It's just not a practical test. We need another test. So if you'd asked me 5 years ago, do we have any problems of bonding hot mix to concrete? I would have said no. I've done a lot of work with the Houston district. The Houston district, for years and years, have had great success using asphalt rubber. They put that down on top of the concrete, and then they put their overlays on top of that. The photograph on the left there is a section of State Highway 6 just south of Clay Road, where after one of the hurricanes it was underwater for 10 days. Before they opened up that road, they wanted to know, man, do we have a problem? Do we have washouts? Is this hot mix going to come flying off when we put traffic on it? So they asked us to do an evaluation. We did. That was about 2015. And we had to prise that asphalt off the concrete. It was still stuck down like nobody's business. You can see the asphalt is black and sticky, and we really had a tough time. So we said, man, just open up that thing. There's not a problem with that. As I said, that was in 2015. After Hurricane Harvey, some of the area offices south of Houston were having problems. We went and did the same thing. This was not bonded. You can see there's no stickum on the concrete. That's the concrete right there. That stuff was loose. So what's going on? Both of these things were type 2 hot rubber seals. So to us, we never really did get everything lined up, what's going on here. But the materials are changing. Back in the old days, there was one supplier of asphalt rubber. Now there's multiple suppliers of asphalt rubber. A lot of this work is done at night. The spec says you've got to have 80 degrees and rising to use asphalt rubber. And so some stuff has changed from 2015 to 2018. So we dig into a few of these things, these recent failures. This is a couple of projects that I've looked at. This is the one, another one of the failures. Again, you can see that the hot mix has just popped off the concrete, and the concrete is clean. It looks like it never saw any seal coats or any seals there. This was the same configuration. This was an asphalt rubber job with a thin asphalt overlay. This other one here is up in Dallas. This is on the North Dallas Toll Road. In every one of the bit corners here, the mix is slipping. You look at it closely, and you can see the raw concrete here. This was a job where they'd used a spray paver and an ultra-thin bonded wearing course. The toll authority is not very happy with this project right here. This is right through the ritzy area of Dallas. So other concerns. I go and do a lot of work in various places, not just bonding to concrete, but what's been pointed out to me by the contractors is some of the patching materials that we use on concrete. We have a heck of a time getting anything to stick to these things. This one in particular is this green stuff here. The job itself is fine, but the green stuff there is problematic. I think Darlene told me that they broke Heineken bottles to go into this stuff, and so we're blaming it on Heineken breweries. I'm not sure that's the case, but whatever. The other thing over the other side here is a topic for another day, but this is trying to bond asphalt to rubberized concrete. And we have real issues with that. You can see that's a job in Dallas where we're just picking up the mat. But at any rate, getting to doing some of these failure investigations, when we go and look at what's going on here, we put a little crowbar underneath that, and you can peel this stuff up with your hand. Every time you move this stuff up here, you see it's wet. And there's just moisture underneath this seal. That's one of the jobs. I think I skipped. This is another project, State Highway 35. We used a little bucket here, and as soon as you wedge it up with the bucket, you can see the moisture underneath there. So there's moisture underneath all of these seals, and that has a big impact on making these things stick. Just to follow on from what Darren was talking, Cindy Stackery is the one that introduced me to this test. It was she'd used it in the past for flooring, and so we thought it would be a good idea to look at it for this particular application here. This is the case that Darren showed. You take a 2-inch core barrel, you core into the concrete, and then you stick one of these aluminum mounts on the top. You fill the cord area with the sand, and then you glue it on and you pull it off like we have there, just to show you the test in action. As I say, you can do this test in the field and you can do it in the lab. It just gives you a straight reading of the force vertically. There's 111 pounds there to do that pull-off measurement. The thing, as Darren mentioned, you can get failures in various places. If the mat is very new, you can actually fail inside of the mix itself. But what you're looking for mostly is to try to get failure like the second one across there, where you're failing at that interface there. As Darren mentioned, you can do it in the lab, you can do it in the field. This is lab work. What we did here was, because of the moisture business, we decided to do testing on a dry core and on a wet core, wet surface. And we went ahead and we tested some available asphalt rubber materials, molded the samples up like in the lower corner down here. This is two different suppliers of the asphalt rubber. And these results show you two things. This is supplier A of asphalt rubber, this is supplier B. These are both supposed to be the same materials. This material A looks like it's supposed to look. It looks like oatmeal. You can see the rubber particles there. This was supplier B, and it's very smooth, looks different. The impact of moisture is shown here when you're sticking the binder to the dry core or the wet cores. These comparison results here are showing you the wet and dry strengths. It's hard to read that thing, but one of those things drops from 80 psi to 20 psi, just when you're trying to stick the stuff to the wet materials. And not just that, is when you look at the materials after you've done the test, when you had the wet cores or damp cores, this whole thing just peels off. The results we're getting in the lab look very much like the results we're seeing in the field there. This is follow-on testing similar to what Darren was showing. This is the material from the Dallas job, which had the EBL, the spray paver. And the one thing we noted here is we did shear tests where we shear it that way, and we did pull-off tests where we go that way. The results are shown here. If the material here with the wet state, you had around 15 psi on day 1. With the pull-off test, you had around about 15 psi on day 1. As you left it standing in the lab, the strengths increased. So after 28 days, you're up at a very high strength, around about 70 psi. So there really is a gain in strength with time going on here. How that relates to the field, this is the problem area up in Dallas, where we did the pull-off tests up there. The results we're getting here are very, very low. This is a 1-year-old section here. The results should be up 70, 80 psi. All the results we're pulling here in the patched area were around about, less than 20 around about 20 psi. So the conclusion here is that the field strengths after 1 year are similar to what we got in the lab after 1 day. There was no gain in strength with age. And of course, in the lab, you leave those samples sitting, and in the field, they're under traffic. So they're being trafficked in the field. So I can skip over this one. This was just more indication that from the GPR data that moisture is part of the problem here. When we had the failed areas are where those arrows are. When we had those failed areas, we had increases in the surface dielectric, which are related to moisture. So there's definitely a moisture problem going on here. So just to wrap up my presentation, as I say, I haven't been doing research. I've been looking at things happening in the field. The failure mechanism is not well understood, but from what we've seen, moisture is a big part of this problem. So we need some kind of test for moisture. We need to improve the specifications. Specifications in my book is very light at the moment. It says something like, if the conditions are not right, don't do it. Well, we need to define a little bit better. Should we say don't do it if it's rained within the last 2 days? Or can we put together some kind of test that you can put something on the pavement to say, man, the moisture conditions are not right. And that could be something like we do for thermoplastic, Darlene, is that right? There's a thermoplastic test where we stick some plastic paper down and we see if there's moisture coming out of the pavement. So moisture has been a part of the problems that we've seen here. As coming from A&M, I've got to say more research is needed, but heck, they give the research to UT, so what's up with that? More research from the right university is needed. We're getting in trouble with these UT guys. All right, current best practices. In my book, from what I saw 5 years ago, asphalt rubber is still the best. But we've got some issues with asphalt rubber, whether it's the suppliers or we're not doing it right, I don't know. The Houston district has moved to AC25TR with their seals. These are the projects I've seen have been on the major highways. I've been on Interstate 45, we've been on Interstate 10, US 59. These were jobs done 5 or 6 years ago. Those jobs are still in great shape. There's not any problems with those jobs. It's some of the more recent stuff that we've got problems with. So anyway, that's what Houston's doing right now. I'm not sure of the usage of the trackless tack. I don't know how many people are using that. The spray paver is fast. The downside of the spray paver is that you don't get a chance to inspect what you're doing. It's sprayed down, it's overlaid immediately. You what do you test? I like shooting the seal and making sure the seal's good before we put the overlay on it. So at any rate, we did some work with the spray paver on Westheimer, and it worked fine there. But as I showed you, the results from the Dallas project does not look so great. So at any rate, the jury is still out for the spray paver when it's directly on top of concrete. That's about all I have. Like I say, I've worked on several projects, and you wanted to sort of applaud the contracting industry when they had a problem. This is what we did on Westheimer. Now, not we did, this is what the contractor did on Westheimer, just to make sure we had a dried surface. He brought in heating equipment and blower equipment from racetracks to run it down the road just to make sure that surface was dry. He did it off his own nickel. So that was, and it was slowing him down. He wanted to make sure he had a good surface, so he brought that in himself. Okay, that's all I have, Andreas. Thank you.